But it just, to me, highlighted we don't really know much about marine heat waves around the UK. What do they look like? Where do they occur? How long do they occur? We don't know, because as I said earlier, they're defined statistically. So we know they've been happening, but we just don't really know what they look like. So so then I decided I'm going to go after that study and see what they look like.
Welcome back to the National Oceanography Centre's Into the Blue podcast, where we talk to the people leading the way in raising the profile of the ocean through research, exploration and advocacy. We hope you enjoy today's episode.
Hello, I'm Sunka Trace-Kleberg, and I'm joined today by Dr. Zoe Jacobs to talk about her recent work on the threat of marine heat waves to UK waters and what's needed to improve our resilience to them. Welcome, Zoe.
Thank you so much.
Normally you're sitting here in this seat. How does it feel being on the other side of the table and a guest instead of hosting?
Bit weird, to be honest. I'm not sure I like it. No, it's actually a really good chance to talk about my own research for once, which I'm incredibly passionate about. So yeah, just grateful for the opportunity to be sitting on the other side, but as long as I'm back in that seat next time.
Fantastic. So I guess to start us off, how did you get to where you are today? Like, tell us a bit about your background and what brought you to NOC.
So I've always loved science, all from like when I was younger and things. But I actually used to want to be a vet. So I spent a lot of my kind of school and college years working in vet surgeries, working on pig farms, dairy farms, going lambing, working in an abattoir. So very different. And then it suddenly dawned on me when I was applying that I think I just love science and animals, and maybe that's not the best reason to want to be a vet. So at the time, I was really enjoying my geography A level. I was really started to become fascinated by the impacts of climate change and things like that. So I kind of did a 180 and did a geography degree instead. And there I kind of developed a love and a passion, I guess, for still climate change, but also the weather. So then I did a master's in meteorology. And there I kind of went into a bit more about the ocean. And then I did my PhD here at NOC on the Gulf Stream in the North Atlantic. So kind of an interesting journey, I guess, to get to where I am. And that was, I think I started my PhD about 11 years ago, and I've basically been here ever since. Yeah.
That's so cool. Really nice to see that it's not necessarily a straight path, that it can kind of change as you go, and kind of follow that thread of the passion for science and where that takes you.
Yeah, absolutely.
That's so cool. How did you become the regular podcast host?
I don't actually know, so it kind of just happened. No, it probably comes from the fact that for a large project called Solstice that I was doing straight after my PhD, actually, when I started working at NOC, I ended up becoming the presenter of a MOOC, which is a massive online open course. So I ended up doing, I presented, I think, over 30 lectures to camera. Mm-hmm. So I guess I picked up some good presentation skills there, and then they were looking for a host and they thought they'd ask me, and I guess must have been all right because I haven't left since. So. Yeah.
That's so cool. So taking a little bit more into the science that you've recently been doing, you've published a paper on marine heat waves. Yeah. For any listeners that don't know, can you just give us a bit of a background? What are they?
Yeah, sure. So marine heat waves, so just like we have heat waves on land and in the atmosphere, we can get them in the ocean as well. So marine heat waves are just periods of extremely warm sea temperatures. And they are defined statistically. So it kind of means that they can happen in any part of the global ocean and any time of year as well. One of my favourite things to tell people is that marine heat waves are not just occurring in summer, they can occur in winter as well. So
I did not know that.
There you go. But they are extremely variable. So as I said, any part of the ocean, any time of year, they can be in like really small patches of the ocean, or they can cover vast areas of the ocean basin. And by definition, they have to last 5 days to be classed a marine heat wave. So the shorter ones are maybe like a week long, but they can occur for months. And even in one extreme case, they can occur for years.
Oh gosh.
Yeah.
So quite variable then, kind of in like the size and like in the length of time as well. Does that then change how the impacts that they have?
Yes, definitely. And the impacts that marine heat waves have are extremely varied like around the global ocean. There are so many documented impacts now from different events. And often the most extreme impacts occur from the longer, larger, more intense ones, like as you maybe would expect. But some of the kinds of impacts that they can cause, so they're highly variable, as I've said. So, for example, they can cause major damage or mortality to important habitats like seagrasses, for example, or kelp forests. Obviously, coral reefs don't really do well when there's a heat wave that comes. We can get some major bleaching. Fisheries, another major impact that they can cause. So they can actually cause the kind of reorganisation of fisheries in a certain region. So what happens is if you get, especially quite an intense or large marine heat wave, certain fish species won't be able to tolerate those temperatures. So if they can, they will move away or dive deeper. I think tuna, for example, can go deeper to get away from the surface warming, or they die. So you can have impacts on the fish catch in these particular regions. But you also have, in addition to some fish species not doing well with marine heat waves, you might get warm water species moving into the region. So you might have a sudden appearance of new species coming into the region. And as I said, that can kind of reorganise the fisheries and lead to impacts on land. So it can affect the regional blue economy, obviously with fish catches going up or down or whatever's going on. And then that can also affect people's livelihoods as well, especially if they work in the fishing industry. But overall, they're quite complex, and the impacts from marine heat waves are often cascading. So one example I always really like to think about, just because it's so varied. So earlier I mentioned there was that really extreme event that lasted for over a year. So that was from it's called the Blob in the North Pacific. And it lasted over a year, covered a huge portion of the North Pacific basin at the time. And at some point during this marine heat wave, there was a huge initiation of what's called harmful algal blooms, which have toxins in them. And that obviously gets ingested by lots of different species. It works its way up the food chain. And what happened was seals were ingesting it, and it basically meant they were poisoned. And the toxins got to their brain and started causing them to act a bit strangely. And then they were basically appearing on Californian beaches, behaving in quite weird ways. And it was quite distressing to the public. It got reported quite widely. So you can see how it kind of can go up the system all the way to kind of the public being upset, being an impact from this kind of thing.
Yeah. Amazing how you say something that starts maybe quite far away that people don't actually get to experience, and how it then comes to impact at our shores.
Exactly.
How do you think climate change has an effect on this?
The short answer is that climate change is definitely going to amplify the impacts of marine heat waves. We've already seen an increase in marine heat wave activity. Obviously varies around the world, but in general, marine heat wave activity is on the rise. We're seeing more frequent marine heat waves. They're lasting longer. They're becoming more intense. And then the impacts are coming with that as well. And it's quite important to remember that while we have background warming happening, like we're anticipating a couple of degrees warmer, it's actually the sudden shocks to the system, like marine heat waves, that are going to cause the most impact. Because if you think we have 1 or 2 degrees of warming over, 100 years or whatever, species might be able to adapt to that warming, but it's these sudden shocks of 5 degrees warmer than it should be for this certain time of year that can kind of cause catastrophic impacts. So climate change probably not the best for marine heat waves.
And I guess we notice that on land as well. Like if we have a really hot summer, then kind of the struggle that we might have, as opposed to just gradually like getting toastier.
Yes, exactly.
Bringing it a little bit closer, because you've recently published a paper on the impact to UK waters. So kind of what led you to conduct this study?
Well, some of you may remember that last year, so 2023 in general, was a really, really hot year for the ocean. It broke lots of records. And in June 2023, an intense heat wave arrived at the shores of the UK, and it was quite widely publicised by the media. I was on maternity leave at the time, and I was kind of interested in what was happening. I was kind of spotting what was going on. And while it was an intense marine heat wave, I think it was about 4 to 5 degrees warmer than usual for that time of year, what got my attention when I started looking into it a bit more was actually it only lasted for about 2 weeks, which is quite short. As I've just said, there are some that can happen for months or even years. So it's quite short. And it also occurred in June, which is not the peak of the seasonal cycle for the ocean. So the warmest time of year for the ocean is probably like much later, so like September. So to be frank, my first thought was, what's all the fuss about? Because yes, it was intense, but it didn't last long. And also the temperatures, the 4 to 5 degrees of warming, the kind of organisms and species that live around the UK can probably withstand that, because it probably reaches that by September anyway. If it happened in September, that might be a different story. And really, it just brought to my attention that we don't really know much about marine heat waves around the UK. We've heard of lots of different events all around the world, but because this one was probably the first major one in recent years, that's obviously why the media got hold of it and publicised it, which is great to bring awareness to it, don't get me wrong. But it just, to me, highlighted we don't really know much about marine heat waves around the UK. What do they look like? Where do they occur? How long do they occur? We don't know, because as I said earlier, they're defined statistically. So we know they've been happening, but we just don't really know what they look like. So so then I decided I'm going to go after that study and see what they look like.
It sounds like you had loads and loads of questions. Were you able to answer any of those? I mean, what were some of your main findings?
Yeah, well, so the first thing I did in the paper, I should just say, this was a classic. It was meant to be just a quick little paper that ended up kind of going down lots of different angles, as it always does. I always say I'm going to write a quick little paper, and it never happens that way. But whatever. It was a really good study. I really enjoyed doing it. So the first thing I wanted to do was exactly what I just said. So characterise what marine heat waves look like around the UK. So to do that, we used some satellite observations, and we basically found that, so on average, so I think we used data from about over a 40-year period. So on average, the UK tends to experience about 2 to 3 marine heat waves per year, pretty much everywhere. Okay. This is on average over the 40 years, mind. But when you start thinking about the length of the marine heat wave, the duration or the intensity of the marine heat wave, some hotspots started to emerge. So what we found was that the English Channel and southern North Sea tend to experience longer but slightly more moderate intensity marine heat waves, whereas the eastern North Sea tends to experience more intense but shorter marine heat waves. So those are the kind of two like hotspot regions that kind of appeared when we started looking at that. And then obviously, as I said, that was on average. So I wanted to kind of have a look at some case study events. So I picked out a few events just pretty much by random, just to kind of highlight how variable marine heat waves are around the UK. Because what I found was that for some of these kind of more major events, they pretty much occurred all around UK waters. So their location was very different. Their strength was very different. Some of them were just 1 or 2 degrees warmer than average, and some were like 5 degrees warmer than average, so much more intense. The duration varied. So some were like 1 or 2 weeks, and some were like so the longest one was I think 5 months. And also time of year, as I said earlier, marine heat waves don't just occur in summer. And actually that long one that occurred actually happened in the English Channel from January to May. So a winter-spring event. And then it dawned on me that actually it could be quite interesting to see what the impacts on biogeochemistry were in this region. So when I say biogeochemistry, specifically here, I had a look at the impact on chlorophyll and oxygen. So chlorophyll is a proxy for productivity, so kind of phytoplankton biomass, the base of the food chain. And what I found here was basically nothing much. It was quite an unpronounced signal. Some events tended to increase chlorophyll concentration, or just coincided. It might just be coincidental, I don't know. So indicating that the marine heat wave may have caused a phytoplankton bloom in that region. Other events saw a decline in the chlorophyll concentration. Other events just had nothing at all. So my gut is that we need to do a lot more research into that. And I suspect that part of that reason is probably dependent on the time of year that the marine heat wave is occurring, because if it's occurring in summer, it might kind of general thought process is that if the marine heat wave is occurring in summer, that the chlorophyll would reduce. But if it's occurring in winter or spring when it's cooler, the kind of injection of heat might kind of initiate some productivity there. So yeah, more research needs to go into that because it was quite unclear, and that is quite important because that could affect our fisheries as well. So that's kind of the main reason why I wanted to look at that. But we did find, though, that marine heat waves tend to coincide with extremely low oxygen concentrations. So we're starting now to think about multi-stressors where you have a marine heat wave, which is extreme temperature, and also a very low oxygen event. An extremely low oxygen event. So the kind of greatest relationship, I guess, we found was in the shallower regions in the south, so English Channel and southern North Sea. So this could be quite important here in terms of multi-stressor impacts on our benthic seafloor ecosystems.
That sounds fascinating. And I guess also, as you say, kind of categorizing them, because there seem to be so many different variables, whether it's the length of time, kind of the temperature, the time of year, to whether we can neatly box them and then understand a little bit more about exactly what is going on. And so what do you think needs to happen or to change, I guess, to mitigate the effects of these marine heat waves?
So the main couple of things I was thinking about that I would kind of want to come from this paper, if you like. First is that we clearly need to do some more research into the impacts of marine heat waves in this region. So I've kind of categorised them. Some people have done some work on what drives them, but we still don't really know what the impacts were from, for example, that June 2023 event. And in general, we don't know. As I've shown, the chlorophyll is responding quite differently. So it's quite unclear what the impacts are. And also, I know that there were impacts because I've heard kind of anecdotal evidence from other scientists or from fishing communities that after that June 2023 event, there were some things that happened. So there was a big die-off of whelk in the Thames estuary. I think something happened with the seabird reproduction in some certain areas. So I've heard that there were impacts that happened, but they're just not kind of systematically recorded yet. So I think we need to do a bit more research into understanding those impacts, which as I was talking about earlier, some of the other kind of major marine heat waves can kind of cascade and go up the chain and start impacting society as well. So yeah, more research always. And the other thing I would say for this region in particular is that although we're kind of not a major hotspot at the moment for marine heat waves, I think I know that they are projected to increase everywhere, but for this region as well. So we kind of need to take advantage of our head start, learn from other nations around the world who do deal with them quite frequently, like in Australia, for example, and just try and build some of their practices in, whether it's forecasting, adaptation, whatever it is, to just try and increase our resilience to them.
That's so cool. And I'm glad you pointed that out because I was about to ask, is there stuff that we can learn from other countries that we can then kind of take what they've already done and then apply it for us?
Definitely. There are so many cool things going on around the world. There are people planting like heat resilient seagrass, for example, or corals actually as well, I've heard. There are some really interesting adaptation options that I've heard about coming from the Mediterranean where in their aquaculture nets, they can... I think they're called submergible aquaculture nets. And they basically, if there's a marine heat wave going on, they can just submerge them. So they just lower them so that they're protected from the surface warming. So there's some quite interesting things going on. So yeah, definitely worth learning from other countries at this point.
Yeah. And I guess, as you said, like a really nice space to have that head start so that you can kind of build that resilience in. So what's next? You mentioned a lot about more research. I guess this is a field that we can answer many more questions in. So yeah, what are you working on?
Well, I do actually have something else in the pipeline at the moment. So from this paper, actually, you may remember earlier in the year, we had Katia Popova coming onto the podcast to talk about socio-oceanography. We ran a socio-oceanography workshop here at NOC last March. Was it this year? Yeah, it was this year. Sorry, time is kind of evading at the moment. And I led a theme on marine heat waves. Which was really cool. I managed to get a really interdisciplinary team together from all different institutes and universities around the UK. And And what I decided to do was use this kind of workshop over a couple of days to come up with a bunch of priority questions that we need to answer to understand the risks and opportunities that may come from marine heat waves around the UK. And I think at this workshop, it was kind of chaotic. We had like a big poster board and like lots of post-it notes going on everywhere. I think we came up with about 350 questions, which was a lot. I was very frazzled by the end of that workshop. But since then, we've actually written up a paper, narrowed it down to 40 questions. But this paper was covering all kinds of things. So we had like the physical characteristics, ecosystem impacts, blue economy impacts, impact on natural capital, forecasting capabilities, adaptation options, the use of social media. How can that help us with this? And it ended up with human health as well. Human health is a really interesting one, actually, like the spread of pathogens and all that kind of thing. And then we ended up with some policy and funding recommendations for future. So it's kind of a different paper than I'm used to writing, but no, it was really good. And that is submitted now. So with any luck, please keep your fingers crossed, that will come out at some point next year.
That sounds so cool, and like an exciting area that you can kind of continue to explore in and see how that changes.
Yes, absolutely.
And I guess also really nicely linked into policy, so the impact that it will have on our lives.
Yes.
So yeah, I mean, thank you so much for joining me. It's been fascinating to talk to you, and I've learned so much about marine heat waves that I didn't know before. And yeah, I'm sure we'll see you back hosting the next podcast.
Awesome. Well, thanks so much for having me. It was nice to have a chance to talk about my own stuff once, as I said. So yeah, I'll be back in your seat next time.
We hope you enjoyed today's episode of the podcast. To ensure you don't miss out on future episodes, subscribe on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts. See you next time.